Hey, and welcome back to another video about identities. This section, we're actually going to talk about verifying them, which is kind of nice because that means they're already going to be providing us with the result, the answer that they're looking for. We're just going to have to verify by proving, basically, that one side is indeed equivalent to the other. So, start with a few notes. All right, so like I mentioned, there's going to be a fairly different way of doing it in the last section. We're going to be given an equation this time, and we're going to make sure that it is equivalent. All right, by working one side to prove that it is equivalent to the other, or some other techniques that we'll see when it's really difficult on both sides. Okay, so a bunch of different ways to do this, and you're going to have different looks. You could be sitting in a classroom next to your neighbor, and they do it a completely different way, and that's okay. All right, just make sure that you pay attention to what you're doing and apply the new identities. And again, I'll put air quotes around new. A lot of them are stuff that we've already talked about. We're just going to have them by name now: Pythagorean, reciprocal, things like that. So just try to avoid any mistakes of rewriting those incorrectly, because that could lead to frustrations on your part. When you were doing the algebra part correctly, but you just didn't write down the identity correctly, and that can be frustrating for sure. Okay, so one more thing, as far as notes go, uh, just make sure that if the path that you started out on didn't get you to a place that you thought you could finish, or the desired result that they told you it should be equivalent to, it's okay. All right, take a deep breath. Don't look at that as wasted time. That's how we learn. Okay, just make sure that you go back and try a different route. Don't do the same one, of course, right? Because that didn't get you to the result that you wanted. So um, just keep trying. It's not okay to stop and give up, right? You won't learn and progress that way. And don't be afraid to make those mistakes. That's how you will learn and eventually get to the right solution. Okay, so a couple of things I want to talk about before we move on to actually seeing how this is different. Not a lot being thrown at us that's new in this section, so that's good. We're not adding more identities yet. We'll get there, but just learning how to work with these a little bit differently than the previous section when we were just simplifying them. Okay, so the procedure that we're going to be utilizing in this section is to, like I said, verify the identities. And that's not the same for solving equations. Okay, there's not necessarily going to be an unknown. We're going to just be given things on both sides, and we're going to have to just, like it says here, verify that they are equivalent. Okay, so a few other things I wanted to mention: that in solving equations, we oftentimes will add something to both sides or subtract, multiply, divide. We're not going to be doing that when working with one side, because if you do that, you're already saying that they are equivalent. So for us to be able to prove that one side is identical to the other, we have to work with just one side, okay? And shouldn't be doing and treating it like they already are equivalent, like we've done in most all of our past career in math. We're going to be using the strategy of working with one side and then rewriting it to match the other side. Okay? Try not to use any of the things that we talked about up here, adding or multiplying, dividing to each side. That's assuming that they're already equivalent, and therefore we wouldn't have to verify anything. So we're going to be working with just one side and trying to match it to the other. Matching identically, saying that they are equivalent. Okay, so the good news is that is the notes for this section. So not much is new other than how we're going to be working with all those identities we talked about in the previous video. But before we actually get to doing these examples, I wanted to make sure that I kind of given you a map, a roadmap of how to work on these things, because there's no real notes. You're going to have to utilize your previous algebra as you can see here, will come into play, factoring, things of that nature, adding and subtracting fractions with unlike denominators, things like that, okay? So a few hints I'm giving you here for verifying these identities. And the first is make sure you know them, okay? And don't be afraid to rewrite them in a different form, okay? So remember, one of the Pythagoreans I told you to memorize was sine squared plus cosine squared equals 1. But what if you just had sine squared? And it would be of interest to actually rewrite it in terms of cosine. Well, then you can do that by just manipulating it, okay? The most important step, I think, in this whole thing is try to rewrite the most complicated looking side, right? Because then you can just treat it as a simplification process, just like we did in the previous section. So just take the uglier looking side of the equals equation and try to simplify it. And most often or not, it'll actually end up being what they wanted you to prove on the other side to verify, okay? But make sure that you keep in mind that other side and what you're trying to rewrite it as, right? Sometimes, step 3, you're gonna want to rewrite things in terms of sine and cosine and then simplify, right? Sometimes, not all the time. But knowing all of those identities, that's why it's number 1, right? Knowing all of those identities is paramount. You have to know that first, then work with the more complicated side. Sometimes rewriting in terms of all sines and cosines can help. And then making sure that you know your algebra skills, meaning some of those operations that we've learned throughout our careers, okay? Like when you're given something like this, knowing that it can be written like that, or even a difference of squares, x plus y, x minus y. Now, what's going to be more difficult and more challenging in this course is they're not going to just be x's and y's. They're going to be sine thetas and cosine thetas. So for example, if I gave you sine squared theta minus cosine squared theta, that is not equal to 1. It would have to be a plus in between them, addition sign. So what can we rewrite that as? Well, you can treat this as an a squared minus b squared, which you should know is a plus b times a minus b. The only difference is our a is sine theta and our b would be cosine theta. So we could rewrite that as sine theta plus cosine theta times sine theta minus cosine theta. So what I'm trying to show you is that the process is still the same. It's just going to look a whole heck of a lot different now that we are in trig. All right? So there's a few little examples here. And again, multiplying by that fancy 1 is one of the most important things that you will ever learn to do in math. Okay? It's a key concept, not only when you are growing up in learning the basic arithmetic skills in elementary school, but you can see it's coming back around in trig. All right? So use this as a nice way to kind of go through the steps, but ultimately, I don't want you to memorize this. I want you to be able to get through these problems as quickly and easily as possible. That's the goal. All right? So just make sure, last few things here, when substituting, make sure that you're substituting in appropriately, okay? Now you could have substituted this because you recognize that as a Pythagorean, or you could substitute this because you recognize it as a reciprocal function, okay? But just keep in mind the end goal. That's the nice thing about this section. They're going to tell us what the end goal is. We already know the answer. We just have to prove to them that indeed it is that by being careful about our algebra usage and then our trig identities. So the last thing, number 6 here, you can see that sometimes it pays to multiply by this thing called the conjugate. And it's not the opposite, because the opposite of a positive 1 would be a negative 1 in the negative sine x. So we're only changing the sign in the middle of these. And hopefully you can recognize those as an a plus b and an a minus b. Because when we multiply those things, that's just working the opposite direction that we did over here. And when we have something like that, we would then have 1 minus sine squared x if we had 1 plus times 1 minus sine x. And again, that would hopefully yield the knowledge of another identity by just subtracting over the 1 minus sine squared, and therefore we could replace this with cosine squared. So it can feel like you're going down a rabbit hole sometimes in these, but remember the key is do not give up. Okay? If it doesn't work the first way that you tried, just start over, and sometimes even skip it and come back. All right? Because a fresh mind, a clear mind can sometimes be the key to doing any and all of these. All right, so that's it for the notes. Not a whole lot going on as far as new things, but utilizing a lot from our past in respect to algebra and even arithmetic, now coupled with these new trig identities. So let's check out example 1. It simply says to verify, and that's pretty much what every one of these is going to say. Now remember, the first thing I told you to look at is which of these two sides of our equal sign looks more difficult. And obviously you should have seen I had to make a lot larger circle around the left side than the right side. So I'm already thinking that this side looks simpler. So I'm going to start by trying to rewrite this side. And oftentimes you can just do what it says. All right, so this first example tells me to take this, which is secant theta, and multiply it times both sine theta and cosine theta. Now the first thing I'm going to do is rewrite secant theta as 1 over cos theta. And that's what I'm going to actually distribute. Because then what I would get by making it a fraction would be sine theta over cosine theta, multiplying straight across. The 1 times the sine and the cosine times the 1. And then doing that here, I would get plus cosine theta over cosine theta. And remember, our end goal is to prove that these are indeed equivalent. So I have my 1. Anything divided by itself is 1. Plus, I know that this is equivalent to tangent. So my answer is 1 plus tangent theta. And some of you might be saying, no, it was tangent theta. Same thing when you're adding 2 plus 3, that is equivalent to 3 plus 2. But remember, 2 minus 3 and 3 minus 2 are not. Okay, that would be a negative 1, and this would be a 1. So when adding, it's okay to flip-flop the order. That's called the commutative property. So whether you write tangent theta plus 1 or 1 plus tangent theta, we have proven or verified that these are identical, equal. And that's it.